Hey everybody, Mr. Bowman here. In this video we're looking at 2.6 algebra, so the level 2 calc algebra paper, and in particular we're focusing on all the achieved questions from 2024 exam. So just a reminder, all these questions are kind of past NZQA exam papers, and I've got a link of all the achieved ones in the description to this video if you want to check out more. So let's get into question number 45. And we've got the equation of the function x squared plus 8x minus 5, and we've been asked to put it in this form. So this is basically a fancy way of just saying complete the square. So hopefully you've done that in class with your teacher, but if not, I'll give you a bit of a rundown. So if we jot down our expression, so x squared plus 8x minus 5. So the way I taught my class is I need to find 1/2 of this here, which is going to be 4. Once I've found that number, whatever the number that is, I need to square it to get to 16. So I'm going to do some math trickery here. So we've got x squared plus 8x plus 16. So this bit here is the completed square. So if I factorize that, I'll get a perfect square. Because I've added 16 to my expression, I also need to go minus 16. And then I mustn't forget about the original minus 5. So hopefully you can see there, I've done plus 16, I've done minus 16, that's 0, so I haven't actually changed anything. And now when I factorize this, what two numbers are going to add to the 8 here and multiply to the 16? That's going to be x plus 4 and x plus 4, isn't it? And that would become minus 21. And then all of this here, we can go x plus 4 all squared minus 21. And now moving on to question number 46, find the discriminant of the quadratic equation just over here. So just a reminder, the discriminant is whatever value b squared minus 4ac comes to. And this quadratic formula, once it's rearranged, that'll let you figure out a, b, and c. So let's start off by jotting down our function. So we've got 3x squared plus 2 equals to 5x. So my first step is to move the 5x over to the other side, so it's going to become minus 5x. So I'm going to have 3x squared. I'm going to put my 5x in here, plus 2 equals to 0. That way it's in x squared x number form. Once it's in this form, the number in front of the x squared there, that's going to be 3, that's a. The number in front of the x, minus 5, that's going to be b, and the constant at the end is going to be 2. I can now substitute that into my function, so b squared minus 4ac, that's going to be equal to, so b squared is going to be negative 5 squared. We're going to go minus 4 times 3 times 2, so that's times ac. And now I can evaluate all that, so negative 5 all squared is going to be 25. 4 times 3 times 2 is 24, so I'm going to go minus 24. And all of that there comes to 1. So moving on to question number 47. So this is the third of 5 achieved questions. There's 2 more to come after this. So we've got a question there. It looks like a nice simple equation, and you just got to solve it. So let's get into it. So we've got 3x minus 14 equals 5 over x. My first step here is this divide by x. I'm going to move it over to the other side. So division will then become multiplication, right? So it's going to be x times 3x minus 14, all of that there is equal to 5. I'm now going to expand my bracket over here, so it's going to become 3x squared minus 14x equals to 5. This 5 here, I'm now going to move over to the other side. Positive 5 becomes negative 5, so that's 3x squared minus 14x minus 5 equals to 0. Now that I've got this, I'm just looking to factorize it. So this is our bread and butter kind of year 12 calc factorizing. We start off by doing positive 3 times that. So 3 times negative 5 is equal to negative 15. And we now need to figure out what number is going to multiply to this negative 15, but add to the 14 over here. So that what 2 numbers are going to get that job done. And I'm thinking it's going to be negative 15 and positive 1. Because they would add to that number there, and they would multiply to that number up there. So I'm now going to split my negative 14x. So we've got 3x squared minus 15x minus x minus 5 equals to 0. Just noting, I've just split this up. Oh, sorry, that should be plus x, shouldn't it? So split that up, so negative 15x plus x is still negative 14x, so it's the same equation, so I can carry on with that. A bit of maths trickery like I did for completing the square, so deleted some of those by mistake. There we go. I now factorise my groups, so group number 1, factorise that. Looks like they've got a 3x in common, which is going to become x minus 5. The second group there, they've only got a 1 in common, so I'm going to take out that 1, becomes x squared minus 5 equals to 0. The reason I love this method is if we've got the same bracket twice, you know you haven't stuffed it up, and if you've got different brackets, you can go back and check your working, because it means you would have made a math error somewhere. My common bracket, x minus 5, I'm going to put first, so that's that part and that part. My leftovers, 3x plus 1, that's going to form the second bracket. So we've got 3x plus 1, and that there is going to be equal to 0. I can now solve my quadratic. So my first bracket here, maybe I'll do them over here. So the first bracket, x minus 5, I'm going to make that equal to 0. And I'm going to do the same with my second bracket. 3x plus 1 equals to 0. And now I'm going to solve each question separately, and that'll give me my 2 answers for x for this particular question. So here I'm going to plus 5 to both sides. So my first answer of x is positive 5. Minus 1 to both sides over here. So I've got 3x equals negative 1. Divide by 3, divide by 3. Which means x is equal to negative 1 over 3, so negative 1/3. So that wraps up these 3 questions. Here's 2 more, so let's get into question number 48. So we've got, basically, this is a logo of some kind of doctor data, and you can kind of see the DO, doctor of data, you can kind of see that symbol in the function there. We've been given the area of a circle formula here, and in this question here, we've been asked to find the expression in terms of x for the area of the circle in the middle of the logo. So what they mean by that is they mean the area of this kind of middle circle over here. So the first part to note is that the formula we've got here is heavily reliant on the radius, so we need to come up with an expression for the radius in terms of x. So the way I did this one here was, so if you cut a line down the middle there, we've got this bit here, that's going to be 1 radius, then we've got another radius, then another radius, then another radius. So 4 radiuses, so 4r is equal to x, which means r is equal to x over 4. So that's me bringing over the times 4 to become divide by 4. So now that I've got x over 4 as my radius, I'm going to substitute it into my formula. So the area, as we said before, given to the question, pi r squared, I'm going to take away the r, so it's going to become pi times x over 4 squared. And then from here, we're just going to need to simplify this expression, and that involves expanding out that fraction bracket power thing there. So we've got pi times x squared over 16. And I just want to note, when I looked at this, I thought for sure a lot of people are going to leave that as a 4 there instead of squaring the 4. But that power has to hit the x and the 4, so both need to be squared. And then once I've got that, I can just kind of simplify the numerator. So that's going to become pi times x squared over 16. And that there would be an expression for the area in terms of x. Okay, so we're now on to question number 49. And this is just a simple solve a log question type thing. But there's actually 2 different ways to solve this question, so I want to run you through both methods. So let's do option number A up the top here. So we've got x is equal to log, well, that's a poorly drawn O, log with a base of 5 of 625. So the first way to do this here is, I kind of use this as the snail method. Basically, this x is going to pop over there. So we're going to get rid of that. So we can unwind the log there. So we've got here, this is always the power. And this is always the base. And then this here is always the answer of the question. So we've got 5 to the power of x. So that's kind of me unwinding this stuff here that I mentioned earlier. To the power of x. And that there is going to be equal to 625. And luckily I know my power rules quite well. But 625 is 5 to the power of 4. So what I'm going to do is I'm actually going to use my year 11 algebra here. So 5 to the power of x is equal to 5 to the power of 4. And then here the 5's cancel each other out. X is equal to 4. So that's option number 1 to solve this question. The second way we could do that, and I've just changed blues here. So we've got log 5, 625. The other way you could do this is you could kind of use your power rules from that first step. So the first step still is the same. You still have to switch it over to the index form. So that's going to be 5 to the power of x equals 625. And at this point here, if you didn't know that 625 was 5 to the power of 4, you could use your log rule. So if we log both sides, we're going to go log 5 to the power of x is equal to 625. And then we've got x log 5. Sorry, that there was meant to be log 625, wasn't it? So we've got log 625. And then from there, we can move the log over to the other side as division, because that's times log 5. So we're going to go x is equal to log 625 divided by log 5. And when you put that into your calculator, you're going to get the same answer of 4. So both are going to get you the full marks to that question. Just require a little different skill. That second one was probably a bit harder mathematically. That first one was maybe hard to spot that 625 as 5 to the power of 4. If you didn't see that, it means you wouldn't be able to do that first method. So that wraps up all the 5 achieved questions from the 2024 exam. Hopefully you found it useful. If you want more questions like this, click the link in the description, and that'll take you to, well, we've got question 49. It'll take you to the other 48 or whatever questions.